Alright, students, today's lesson is about functional groups. We are going to be using reference table R as we go through a couple of examples. So please make sure that you have your reference table in front of you as we go through the questions. Our goal is to make sure that we should be able to draw organic compounds with functional groups by using reference table R. So when we are using reference table R, we need to look at the last column where they gave us some examples, and we need to identify the functional group by looking at their end part. For example, if the example is given as propanol, the name propanol ends with OL. And if any compound that has a name that ends with OL, you need to understand that it's alcohol. If it's a chemical formula for alcohol, it will end with OH. For methyl ethyl ether, obviously the name ends with ether, and therefore you need to know that the functional group is going to be ether. And the general formula or chemical formula is usually ROR, where R represents a carbon group. So for an ether, you will have oxygen in the center, and then you have to have two carbon groups on, um, each on both sides, right? Meaning you have one carbon group in the right side, and then you have another carbon group in the left side, and the center would be oxygen. If it's propanol, the name ends with Al. Those two letters represents aldehyde. The first two letters of aldehyde is also Al. Usually, when they give us a chemical formula, um, the chemical formula aldehyde is represented by CHO. They do not write OH because people might get confused with alcohol and aldehyde, and that's why we write OH for alcohol, and for aldehyde we write CHO. We just flip the letter O and H. So in a chemical formula, if they write CHO, don't assume that it's alcohol. Instead, you should know that it's an aldehyde. Then the next example is 2-pentanone, and the name ends with ONE. So that's right away, it's a giveaway that the functional group is ketone. Usually the general formula for ketone would be R bond C O bond R, meaning you have two carbon groups on each side, right? On the left side and right side, the carbon groups might be the same or might be different. It doesn't matter. And then in the center of that compound, you're going to have a carbon group double bonded with the oxygen. So that oxygen is only bonded with carbon. Keep that in mind. And if there is a number in front of the name, like for example, 2-pentanone, that means your ketone group is in the second carbon. The number represents the location of the functional group in this case. Propanoic acid, it should be very straightforward. The name already gave you the idea of functional group, which is organic acid. And you need to know the chemical formula for organic acid because the chemical formula ends with COOH. Remember, it seems, don't just assume that OH, if it ends with OH, it would be alcohol. You have to look in details, and if it ends with COOH, meaning you have two oxygen and then one hydrogen, that's an organic acid. Right, so keep that in mind. Don't just look for OH, just look at the uh, prefix as well. If you see that there is another oxygen, obviously it can be alcohol because alcohol have only one oxygen. Then you have methyl propanoate. If it ends with O8, it's ester. Um, and the functional group seems very similar to carboxylic acid, organic acid in this case, and it ends with COOR, meaning you have a carbon group and then you have two oxygen, and then you have another carbon group. So in this case, for ester, It seems very similar to ketone, where a carbon is double bonded with oxygen, and then you have another oxygen attached to the same exact carbon, and then that oxygen has another carbon group to it. And then we have amine, and again, it's a nitrogen group. The name gives away the functional group. And amide has nitrogen group with a ketone, so it's an extended version of amine. So let's take a look at the example, and as we go through the example, you might understand it better. So the first example is given as 2-propanol. Notice how I highlighted the last two letters, OL, because it gives me an idea about the functional group. In this case, the functional group is going to be alcohol. So always use reference table R when you're solving organic chemistry questions. So if it says 2-propanol, the first thing I would do is like I would look at reference table R and go through all the examples. Go through all the examples from reference table R and see which one matches the given name. So propanol, in this case, it does match with the name that is given for alcohol, right? So I know the functional group is alcohol. So the first thing I would do is I would draw the functional group for alcohol, just like this. So I have dash OH. That's the alcohol group, right? In this case, this alcohol group must be in my second carbon, right? Because 2-propanol means whatever the functional group you have, it has to be in the second carbon. But how many carbons do we have? So in this case, we have to look at the prefix, and we have prop. Prop means we have 3 carbon. So first thing first, I'm going to draw a carbon-carbon chain with 3 carbons in it. So in a single straight line, just draw it as if like you're drawing an alkane. Then draw all the bonds for each carbon. Make sure each carbon has 4 bonds. And then in your second carbon, you have to bring this group, right? In your second carbon, you have to add an alcohol functional group. So for the second carbon, you can draw it at the top, you can draw it at the bottom, it doesn't matter. And then only thing we're missing is like we have to draw hydrogen for each of those empty bonds. So you have to have hydrogens for each of them. I'm drawing hydrogen with black letters, but understand that the blue hydrogen that is connected to oxygen, it's not part of the carbon group. It's the part of the functional group of alcohol. And this is the reason it is attached to oxygen instead of carbon. And we don't have to draw additional bonds for, we don't have to draw the bond between oxygen and hydrogen in this case because it's part of the functional group. However, if you want to draw it, you can also draw an additional line between oxygen and hydrogen for this case. And that's 2-propanol, right? Always focus on the last part first, and that would make your life easier. So next one we have methyl ethyl ether. Some people pronounce it as methyl ethyl ether. It doesn't matter how you're pronouncing it in this case, as long as you have the right idea. You need to know how to draw it. So first thing first, we would look at reference table R. We would see which example makes sense, like in this case, and methyl ethyl ether. The functional group would be ether, right? Because the name is exactly whatever is given in our example. So we need to draw the functional group. The first thing we need to draw is this right here. So I saw an oxygen and then 2 bonds, right? These are not lines, they're bonds. And obviously I have 2 groups. I have a methyl group and I have an ethyl group. And we have to draw them, right? So in this case, your methyl group in the given example is on your left side. And if you divide this name into 2 parts, the methyl group is on your left side, as you can see that. and then the ethyl group is on your right side, right? Ether is your functional group, which we already drew. So we need to draw a methyl group on our left side and an ethyl group on our right side. It's that simple. So don't make things too complicated. So what do I know about methyl group? I know that meth means one carbon. So I'm going to draw an additional carbon on my left side. And what do I know about eth? Eth means two carbon. Don't forget to draw it in a single straight line. Don't make things complicated at this point. And then I have to draw the additional bonds for each carbon. Oxygen has two bonds, so that's it. Carbon can have four bonds, and we should draw four bonds for each carbon. Once you're done, please don't forget to add hydrogens. And that's about it. So we have our functional group of methyl, ethyl, ether, right? The following one is 2-butanone. Please pause the video and figure out the functional group by looking at reference table R, and then play the video to check your understanding. So for butanone, I realized by looking at the example, it sounds like 2-pentanone. It ends with ONE, so that's how I recognized it's a ketone. The moment I recognized it's a ketone, I drew the functional group by looking at the functional group column, or you can also look at the general formula column as well. It says 2-butanone. That means this carbon, the carbon with the functional group, has to be my second carbon. So it doesn't matter if you're drawing from left to right or right to left, it's still the same, but make sure that this functional group carbon is your second carbon. So to make it second carbon, I can draw a carbon on my left. So I already have two. I need to draw two more because but means four in total. So then obviously I have to draw two more on the right side. And then I'm going to add bonds for each carbon and have hydrogens for each of them. And that's your 2-butanone, where your functional group of ketone is in the second carbon. I drew it from left to right. You can also draw it from right to left. All right, so this is a questions. These are questions for you guys to practice. You can pause the video. You can practice them by using reference table R and check your understanding by playing the video again. I'm going to draw these out, so please pause the video at this point. So for the first one, I have CH3COOH. By looking at COOH, you need to understand that it's an organic acid. And again, go back to the previous slides that we covered. And once you know that it's organic acid, you're going to be drawing the functional group column for organic acid, which is in the green. And then I noticed that I have another carbon group with 3 hydrogen. So I just added that blue carbon to the green one. And obviously that carbon is missing 3 more bonds, and those bonds are connected with hydrogen. So that's the structure for CH3COOH. For the second one, it's a ketone where you have carbon double bonded with oxygen, and two sides you have two different carbon group. So if you look at this part where you have carbon and oxygen, you might realize that this carbon right here doesn't have any hydrogen attached to it, right? So the carbon that is bonded with oxygen doesn't have any hydrogen attached to it, and that's how you can recognize a ketone. Some people might misunderstand this in term, they might assume that this is ether, uh, but for ether, oxygen is bonded with carbon on both sides, and both carbons most probably are going to have hydrogens in it. So be careful as you're drawing these structures. You have to understand and you have to recognize the functional group properly. For ketone, usually, generally, the carbon that is attached to oxygen doesn't have any more hydrogens in it. The last one is aldehyde. I knew because the name ends, the chemical formula ends with CHO. And again, these are tricks that you should memorize. And the moment I realized it's aldehyde, I drew the functional group by using reference table R in green. And then I noticed that I have CH3 group left. So I added a carbon to the functional group. And obviously that carbon was missing 3 bonds, and those 3 bonds are hydrogens connected to hydrogens. Um, So these are the questions you should practice going forward. Thank you.